So today the title of my talk is Managing Certificates and TLS Endpoints. So, kind of the inspiration for this, Henry and I, who's right here in the audience, we work on the security engineering team at Rackspace. We're in charge of managing a large number of product endpoints for SSL TLS stuff. So, we kind of have an inside look into some of this at scale, beyond, maybe you have one website, whatever. We have very many to track. So, and since Heartbleed, everyone's kind of paying attention to SSL, or paying a lot of attention to SSL. So all the little things that maybe you got by with in years past, where your config wasn't perfect, now those are heavily scrutinized. So many headaches later, we have a tool that I'll kind of talk about a little bit more in a minute, but that helps us manage all the endpoints that we're dealing with. So let's just start with a very quick primer. So TLS SSL, obviously used for all the good stuff: CIA, confidentiality, integrity, and authentication. It's encryption for data in transit. And so it started off, there was SSL v1, which was never actually a thing that you could install and run with. It was more of a spec. So what we have is SSL v2 and 3, and TLS 1, 1.1, and 1.2. You get it on just about every device. Your phone is probably talking to Google over SSL right as we talk. So there's all kinds of stuff that's using it, and it seems very simple to get set up with, because it's there's a couple config changes and you can get to SSL very quickly. But what we're going to talk about today is kind of what you have to do once you get over that first step. What do you have to do, when you've been managing a certificate and a server for a while. So TLS adoption is increasing. Browsers are starting to call out explicitly. Like in the past, a regular site without SSL looked like, hey, this is just fine. This is totally cool. Now, if you go to any site in Firefox or Chrome that doesn't have SSL, they're going to tell you about it, which is totally valid. I'm happy about that. But it means that there's going to be a lot more SSL endpoints that you're going to have to start managing. So again, it can't just be turned on and left alone a lot of times. But at least some of the things, the cost has come down a lot. In fact, I'll talk about this a little bit later, but Let's Encrypt, which is a kind of a community certificate authority, they have actually just gotten their first certificate trusted, and they're free. So again, TLS is going to just keep going up. So what is it used for? Obviously web services, but email, IRC, all kinds of stuff, VPNs, they all kind of use SSL TLS to some extent. So there's a lot of moving parts. Certificate authorities, I don't want to go into too much detail on this. You guys probably know most of it, but there's lots of little pieces that have to be configured and can't just kind of be left alone. So certificate authorities, protocols, ciphers, all these things kind of add up to having a secure TLS SSL implementation. So like I kind of said earlier, we've got multiple protocol versions to work with. You've got certs of varying issuance dates with different expiration dates, etc. So maybe one endpoint you can kind of set a little reminder in Outlook for yourself to go hey, I need to go renew my SSL cert on this day. But you're going to have a very full calendar once you get enough of these. So there's a lot of other misconfiguration, running on outdated hardware, having a large number to manage, as I've said, is also fun. So intermediate certs expire, so people that are actually signing your cert, sometimes that can happen. Certs can get revoked for various reasons. Maybe somebody checked them into GitHub, oops, time to delete it, revoke everything, start over, redeploy. So you get that. You also get every once in a while, your actual CA will get compromised, and then they have to take all the certs away and do it all over again. So that's fun. And self-signed certs basically get rid of a lot of the good security principles of SSL, so they're kind of useless in a lot of ways. But they get deployed a lot. So there's always new vulnerabilities. Poodle is one of many, but this is in the actual SSL protocol itself. So Poodle's an attack on SSL v3 specifically. You get bugs in the actual encryption software. basically, as you can already tell, right, the point of this is not to delve deep into a lot of these different issues, right? It's just to simply say that there are a large number of things for which you will have to renew your SSL certificates, change the configuration, etc. Regulation compliance, so TLS v1 is going to be deprecated for PCI at some point, and SHA-1 signed certificates are flagged as insecure if they're signed through January 1st, 2017, and the browser is telling you about it now. All right, so maybe you're getting a sense now of how we all feel about this, right? A little humor to brighten things up, right? So there's a large number of things that can go wrong, but the idea here is that, like, eventually you can get it all under control, and it's normal, it's fine, it's normal. All right, so let's get to ciphers. So just quickly brushing over this, but basically when connecting, the client and server have to agree on how they're going to talk to each other, and well, kind of from a security perspective, it's a little unfortunate that the client can essentially dictate the terms under which this takes place. Because they can essentially say, I only support one thing. Do you support that one thing? No? Okay, well, I only support this one other thing now. And so they can basically go along a list of insecure and just bad ciphers. And that's kind of what happens in the logjam attack, where a man in the middle can actually force the client to connect to the server over an insecure channel, basically. Again, very simplified here. So this is what you might be familiar with. If you've dug into like setting up Nginx or anything like that to set different ciphers, SSL ciphers. This long string here, it actually has a meaning. It's not just a bunch of incomprehensible words. So the first bit here is your key exchange algorithm. So this would be Eelliptic Curve, Diffie Hellman. You've got your authentication algorithm, which this one's RSA, and then you've got your key attributes, so AES 128-bit, CBC mode, and then you've got your MAC hash algorithm at the end. I don't want to get too divisive on this, but this is kind of how I feel, and I'm sure lots of other people have different opinions about it. There are lots of fun elliptic curve things that you can support. They have varying support in clients, so you can go way down this rabbit hole. The things on the left there are pretty sane and pretty agreed upon. Again, you can go a lot further, you can go a lot less, but it kind of depends on what clients are you going to support. If you have to, as part of your business, support really old hardware or really old operating systems, it may be the case that you have to use some of this stuff that you're not totally comfortable with, but in general, you should be pretty good as long as you tend towards the stuff on the left-hand side of this. So that's not all. You got plenty of other configuration things to worry about. So again, that table, but this also mentions OpenSSL. So you want to be up to date on your version of OpenSSL. That was if everybody remembers, the fun time that we had in April last year. That's Heartbleed. So we want to be running the newest OpenSSL. Unfortunately, it seems that the SSL landscape is further fragmenting, so update your OpenSSL, GNU TLS, LibreSSL, Boring SSL, and all the other ones. So let's see. Yeah, sometimes you're kind of, unfortunately, hardware sometimes puts you in a bad spot. So you might have hardware load balancers or firewalls that don't support the protocols or ciphers that you want to support. So sometimes you can't even go in there and just twiddle some bits in your configuration. Sometimes you got to call your hardware provider, which is unfortunate when that happens. And yeah, like I mentioned, sometimes the business wants to support IE6, and so you got to support IE6, and that comes with compromises. So here's an example configuration. I won't go too far into this other than to just kind of show you what you're dealing with. There's more in-depth examples of this, and I'll get to this in a bit, but there's a great site called Cypher List, and they have configurations for lots of different things. So yeah, you can get, again, this is kind of just hammering it home. You can get a lot of things wrong, right? So CA bundles, ciphers, the honor cipher order is worth mentioning. That's talking about how essentially when those clients and servers are negotiating how they're going to talk to each other, on our Cypher order says, generally I want to use, like, as the server saying, generally I want to use the things that I have chosen. Let's see. Oh, and this is a fun one. If you've got several servers in a load balancing, let's say in a round robin configuration or something, you hit it the first time, everything looks great, it's all wonderful. And then you get some reports from somebody that, oh wait, actually, you know, I looked at it and you know, I'm getting this horrible, you know, export grade encryption, whatever. So you have to make sure that all the servers have been configured the same way. Perfect forward secrecy is another fun thing that you can enable. So basically the idea with this is to prevent a compromise of the SSL private key from being able to be used to go back and decrypt sessions that have already been encrypted with it. So you think state level actors, if they're sucking up all this data, if they ever get your key, they can go back and read everything. But the idea here is you use ephemeral keys that are used for shorter lengths of time and that you can't get back from the private key to those ephemeral keys. Strict transport security is something in the web realm. So this basically tells your browser, hey, this site should only ever be on SSL. Don't hit it on anything else. We good? Cool. And then your browser basically from then on knows that at no point should anyone tell me that I should be hitting this on port 80 without SSL. I always want to hit SSL. So let's just go over some of the vulnerabilities. Heartbleed was kind of a wake-up call, I'm sure, for more than just me in this audience. That was what I would characterize as a bad day. And then we got, you know, we've gotten several since then that haven't. They've all wanted to be as big and bad as Heartbleed, but they haven't quite wowed us as much. But there's a number, you know. There's things Poodle affecting SSL3. There's an anachronism of the American system, which is the export ciphers, which were kind of rediscovered this year. So there's a mechanism for protecting against TLS downgrading. I won't go too much into it again, but essentially this is just to prevent any sort of monkeying with the connection by a man in the middle for TLS. So export ciphers are a fun thing that are still around today. We had laws at some point, excuse me, saying that essentially you couldn't export crypto if it was a certain level of strength, more or less. And so what they sort of agreed on was you could use these really short keys and that would be okay, right? So you would have what they considered to be sort of civilian level encryption, but the government always knowing that they could probably break it, right? And so if you ever see, for instance, if you're looking at your ciphers or whatever, you're testing an endpoint and you see export, you don't want it. You don't want it at all. We're not under that legal restriction anymore, so get rid of it, throw it away. If you're building a new SSL library, build it out, throw it away. We don't need it. Right? So this might be kind of what you're thinking at this point, like, this seems like a lot, right? I mean, I thought I just kind of plugged in my certificate and was ready to go, but certs expire, servers are reconfigured. If you're in a very fast-moving Chef managed, Ansible managed thing, things are changing daily, maybe more than that. You get new vulnerabilities coming out fairly frequently, whether in the protocol or in the actual software. And just as the slow march of time goes on, we get better computers. As we get better computers, we kind of have to reevaluate. Wait a second, it was supposed to take this long at this time. But we actually got there faster, so oh crap, actually we have to go back and rework all these assumptions that we built in over the years of, oh, well, SHA-1 may not be perfect, but it'll be good until this time, and that time just seems to keep sliding backwards. So to drive home, once again, you need to constantly monitor your endpoints. It's like constantly, like all the time, all day, every day I have to be doing this? Like, I have other stuff to do. SSL is not at the top of my list here. So we've got a couple tools, thankfully, that you can use. This is mostly geared towards the Unix, Linux folks, but the OpenSSL S client is actually pretty great for just debugging stuff. It's not security focused. It's purely for getting the raw information. It'll give you some information about as the handshake's happening, it'll monitor that traffic. It can just give you a lot of detail there. TestSSL.sh is one of my favorites personally. It's a free command line tool. You can read that, but basically it has no setup. It has very few dependencies other than OpenSSL. You can just spin it up on any box, basically any Linux box, and run it, and it's ready to go. And it's more security focused, so you can kind of see this. That could fit the whole screenshot in here, but you can kind of see here you've got SSL v2, v3 not offered. That's okay. So you've kind of got, it'll tell you a little bit about what the good configuration looks like, and what if anything, if something's enabled that shouldn't be, it'll tell you. So it's handy. And then we've got Qualys SSL Labs. So many of you are probably familiar with this one. It's very popular at this point, and actually we utilize it for the TLS Manager that's coming up soon. But basically, they help you condense all this information down, and they give you a nice little score. And the score is really handy if you're passing this off to somebody that doesn't care about SSL, but you hand them a big red F. They know they don't want the big red F, right? They might not know what it takes to get away from the big red F, but they know they don't want the big red F. So this is kind of how the score system breaks down. You can kind of debate some of this stuff. Maybe this is more important than that, but in general, it's a pretty good picture of if you're getting an A+, you're pretty good, right? There may be a little nitpicky things you could change here and there, but if you're at an A+, like for all intents and purposes, you're pretty good. But then it goes all the way down to F. Like I said, if you're using MD5 or you're using 768-bit keys or something, or you're maybe only SSL2 or something like that, then it'll very explicitly tell you that that's wrong. So everyone wants an A, right? You want an A. You want an A+. So this is another one, Cypher List. I kind of brought it up earlier, but they have a lot of good configurations for a lot of different server software. So HA Proxy, Postfix, OpenSSH, Apache, and Nginx are usually, whenever anybody is recommending something about SSL, they have something about that. But you have to go fix Postfix, and that's not as widely distributed. So it's helpful for making recommendations to product teams. But I will have this one little caveat. So the copy and paste part is really nice. But before you send it off to all your devs, I would go take a look at it and make sure it's actually what you want. Because you have to make trade-offs. Like I've said, you have to know who the clients are that you want to support, right? And so this list, these configurations are geared towards giving you reasonable compatibility with, again, some security trade-offs. So you just have to decide for yourself whether that's reasonable for what you're trying to support. But in a lot of cases, if you're just going to use a copy and paste format, you don't want it to be something that the implementer has to go and like twiddle, little bits here and there. Like you want it to just kind of work. And so this is helpful for that. Bad SSL is I love it. Honestly, it's pretty simple, but basically they have a bunch of subdomains set up off of their site, and if you just go to the Bad SSL site, they've got them all listed there. But for you to be able to test, so if you've got some tools or whatever that you're trying to work on, and you're trying to make sure that they catch this issue or that issue, they've pretty much got every way that you can get an SSL cert wrong. They've got an endpoint for you to test on. So it's handy for that. So. This is Putin laughing at you for wanting to manage all those endpoints manually. Maybe none of you do, but if you do, this is what he thinks of it anyway. So this is what we use in our team to kind of keep up with some of this. So I'll get to a video of it in a second, but you can kind of get the idea. So we've got all these endpoints that are associated with a product, and then on the side you've got that helpful SSL Labs score. So what TLS Manager does for you is once you've kind of set up all the products and endpoints that you want to test, you can scan them daily, you can scan them weekly, you can scan them monthly, whenever you feel like you need to. And it'll tell you the SSL vulnerabilities that it finds as a result of that scan. It'll tell you when certs are about to expire. It'll email. So the other nice thing is it helps you be even lower touch. excuse me, you can put in the product owner's email addresses, and it'll actually send automated reports to the specific product owner if you want to do that. And it keeps a history of everything so that you can kind of track things over time. All right, so let's hope and pray that the video works. Sweet. So right now we're just kind of on the main page. So you can see we've got a couple bad SSL endpoints, and they're not scoring very well because they're bad, obviously. So you can sort by any of these different fields. So if you're trying to figure out, what's the oldest, what's the thing that we checked least recent or most recently, whatever. You can check the scores out. So how many failing certs do we have, etc. So you can go to the details, and this will tell you what specifically gave it that score, what's wrong with it that made it, made it an F, whatever. And so you can see how it did over time. So you can see, let's say, for example, that somebody just did a deploy, and oops, we fat-fingered a config option, or we forgot to ship this config, or whatever it is. You can see, well, we were getting an A until this day, and then something went wrong. So you can kind of go back, and that helps you trace back what it is that maybe caused things to go wrong for you. So I think that's about it on this. You can see on the side there the different kind of stuff that you can do here. So setting up a product, etc. I think you guys probably get the point, so I'll go ahead and move on. So you can go get it on GitHub on the Racker Labs /TLS Manager. It's Apache licensed, and pull requests are more than welcome. I think there's probably room for us to support more SSL tests and stuff like that. Like I said, we're mostly working off of the Qualys SSL Labs API right now, but for the most part, it covers almost everything. So let's just to kind of tie this into real life, right? Because everything that I've said so far is kind of in imagination land a little bit. So there was an announcement. Let's see. I guess it's been a couple days now, but Google has decided that all of their products, Chromium, etc., Android, everything, they're going to ditch OpenSSL and they're going to take on boring SSL. Why does that matter? Why do we care about that? Well, as the you can say what you like about how OpenSSL has been managed over the years. It's probably not a code base that everyone in this room has contributed to and reads frequently. It can be a bit of a beast, but as we start fragmenting the landscape, you're just adding more and more and more potential for things to go wrong. And so this is, it's potentially a good thing, right? I mean, you're getting rid of some cruft. Basically, their idea is to take the little pieces of OpenSSL that they want and rebuild everything else. And so, again, it has potential to be good. It also has potential to go wrong. And the more SSL implementations and so on that are out there, the fewer people that you're going to have looking at any individual one of them. So, maybe a win, maybe a loss, but it's another thing that changed. And this is all stuff that's changed since I started working on this presentation. So this isn't, the whole year in SSL. This is like the last couple weeks. So I think I mentioned this briefly earlier, but Let's Encrypt, which is a free CA for issuing SSL certificates, they just, I think this week, got their first certificate trusted by most of the major browsers. And so what this is going to do is, they've been kind of spinning up on this for a while, but they're finally at the point where if they were to hand you a certificate through their process, they don't have, at this point I believe they've gotten away, I don't think they have any other dependencies. They are trusted, so they can start ripping off certs whenever they want, basically. That's probably a good thing, right? It's probably a good thing. There's, it's always good that there's more SSL sites, Personally, I use an extension called HTTPS Everywhere, so this makes me very happy because I hate when I go to a site and even when I try, they have no SSL, right? So this just lowers the barrier to entry. But again, going back to what we were saying earlier, more SSL endpoints to manage, right? So SHA-1 is totally broken. Everyone scream and go crazy. Well, so this was a paper that came out that essentially said, like I said earlier, the SHA-1 sort of deadline of, ooh, it's very scary after this point, that deadline just keeps seeming to move back a little bit more and more. And so this is taken from Bruce Schneier's blog. They've got a full paper about it, but essentially the thing is they were able to find a collision in the compression system of the algorithm. I'm not going to stand here and pretend like I know exactly what these guys are talking about, but what I can tell you is a lot of people see this and they go, ah, you know, they go crazy. But really what this means is that SHA-1 window for browser trust and everything else, it's just moving back. And so I wanted to highlight at the end, just to kind of dial it back a little bit. Final line is free start collisions like the one presented here do not directly imply a collision for SHA-1. So, you know, you can go back to, you know, you don't have to start fighting the fire today, but it's coming, it's on the horizon. We can see it from far away. We can't tell when it's going to get here, but it's getting here quicker than we thought. So, yeah, always fun. And then you have the Diffie Hellman apocalypse, which seems to have come down on us, and the NSA has apparently broken trillions of encrypted web and VPN connections and da-da-da. What this is all based on is essentially the NSA has a budget big enough that they could build a computer that could maybe break Diffie Hellman. And so a lot of the assumptions that all this stuff rests on, they're not fixed. They're never fixed. And so one of the assumptions that this is challenging is, for the longest time, basically everybody packaged up the same sort of primitive pieces for Diffie Hellman, and they'd ship it out with everything, right? So everyone had the same one, but because of the way that the math works and how Diffie Hellman works, et cetera, everyone was like, yeah, that's fine, that's cool, because you're not using it directly, you're using it to seed something and derive something from it. So everyone kind of thought that it was fine, but what they've realized is, well, if you have an $11 billion budget, you can actually do some things that lessen your security there a bit. And so, like, for example, like Nginx and a lot of things, a lot of times they will just come with, out of the box support for the sort of standard default, very widely replicated set of Diffie Hellman's parameters. And that's great news for the NSA, because if they can build one machine, this is what this all rests on. They're going to build one machine that breaks one set of parameters, right? So they're not going to break everything. This whole doomsday scenario relies on the fact that everybody's using the same Diffie Hellman parameters to begin with. It's actually pretty easy to generate your own. It does take a while because it needs a lot of randomness, but it's not the end of the world, as ours might have you believe. So yeah, these are just like I said, tying it back to the real world and very recent history. So closing thoughts. Basically, it's hard, right? I mean, it's really not that hard, right? It's really just that there's a lot of it. But if you can actually keep up on it, and it's not a customer calling you and saying, oh, hey, I can't get to your site because it's broken, or my browser says that it's insecure. It's, you're way out ahead of it. And that's where you want to be, because at any given moment, one of these fun things like, SHA-1 or whatever can drop on you, and then you get to go really fight some fires. So SSL, TLS library bugs, Cypher Suite bugs, protocol bugs, all these things can happen. And so it's really, really handy, we've found, to manage it in an automated way to keep from going crazy. Anybody have any questions? And Henry, I want you to come up here so that you can, help us do some Q&A. He's my co-presenter, everybody. Not very interested in presenting. Everyone gets it. Cool. All right. Sweet.
Well, I had a question.
Oh, yeah, sure.
Oh, I can probably speak up. The question is, could you maybe talk a little bit more about ephemeral private keys? Because what we are used to using in our environment is just private keys, and they're out there with every Apache web server that is deployed. So I personally don't like it, and
I don't think any of us like it.
yeah. So what's the way out? Or
yeah, so it's actually, so if we go back, let me go back in my slides a little bit. Get this guy again. So if you look at it, what this slide is calling out is essentially that on the Cypher Suites, when you're configuring your server or whatever, so Nginx, Apache, whatever you're running, the little E's at the end are supposed to signify that uses ephemeral keys. So it's actually not, I don't think that you have to do anything super special to generate new keys. It's something that's kind of handled on its own. And so if you look out for those ciphers, if that's all that you want to support, then I believe actually SSL Labs and some of the other SSL tools will tell you if perfect forward secrecy is enabled, if there are ciphers that support it, and you can kind of go through the list and make sure that all of them do if that's what you want to deploy. Unfortunately, I can't get too deep into the crypto on it. Unfortunately, not an expert in it, but yeah, it is actually, thankfully, fairly easy to get set up with. So good stuff. Always good when it's just a toggle switch, right? Anything else? So I have one last little bit. I've been asked, let me get to the last slide here real quick. So like I said, I work at Rackspace, and I'm also working on the OpenStack security project, which is the name of kind of the group that does things like vulnerability management. They do stuff like, they issue advisories if there's something in OpenStack that needs a CVE, et cetera. And so if any of you guys work with OpenStack and are interested in getting involved, come talk to me after. There's a IRC channel that you can get in touch with us on Freenode. We have weekly meetings if you want to come tag along and see, kind of what we're working on. There's a couple cool projects. Bandit, which is a Python static analyzer. And actually, this might pertain to you. There's one called Anchor that's for doing ephemeral PKI management. And so I unfortunately can't go too deep on that, but it's an interesting idea, I'll say that. Got a mailing list as well, so if you're interested, like I said, come see me or join up. So thank you.